Have you ever been handed a document at work, a big wall of text, and been told, figure this process out? It's a nightmare, right? Well, today we're going to talk about a super powerful visual tool that takes that kind of confusion and turns it into a map that anyone can understand. It's called an activity diagram. Let's get into it. Okay, so take a look at this. This is a pretty standard description for something like a flight booking system. Now, just try to imagine you're a developer or maybe a project manager, and this is what you have to work with. It's messy. You've got conditions, different user paths, steps that feel out of order. This is exactly the kind of thing that causes confusion, mistakes, and major delays. So that's the big question, isn't it? How do you take that jumbled paragraph and turn it into something a whole team can look at and instantly be on the same page? There has to be a better way, and there is. We're going to build it piece by piece right now. All right, let's start at square one. Every single process, no matter how complicated, has a beginning, a middle, and an end. So we're going to build the absolute simplest version of our flow first, just using the basic building blocks. So what exactly is this thing we're building? It's called an activity diagram, and you can think of it like a flowchart on steroids. The key thing to remember is that it's not about data or code or objects. It's purely about the flow of actions. What happens, and then what happens next. That's it. Now, to build this thing, you only need a few simple shapes. You've got the start node, that little filled-in circle, which is, where it all kicks off. Then you have actions, the individual tasks inside these rounded rectangles. The arrows connecting them are called transitions. And finally, you have the end node, which kind of looks like a bullseye. That's your finish line. Pretty simple, right? Okay, a straight line from start to finish is easy, but real life is never that simple. Real processes have choices, branches, and different paths. So let's add some logic to our flow and make this diagram a whole lot smarter. This is where the decision node comes in. It's always a diamond shape, and it acts like a question in your workflow. Think of it as a fork in the road. When the process hits this diamond, it has to ask a question, and based on the answer, it goes down one path or another. It's basically an if-then-else statement, but for your workflow. And here's how it works. You use the diamond shape. Every arrow leading away from that diamond has to have a condition written on it, in brackets. We call that a guard condition. So for a flight example, one arrow might say economy class, and the other would say business class. Now here's the most important rule. The flow can only go down one of those paths. It's a choice, not a split. So, we've handled choices. That's huge. But what about when you need to do multiple things at the same time? When tasks don't have to happen in a specific order, and you could be way more efficient by doing them simultaneously. For that, we need a totally different tool. And here they are, the fork and join. They look like these thick black bars. A fork takes one path and splits it into two or more paths that all happen at the same time, in parallel. Then the join bar waits downstream. It doesn't let the process continue until every single one of those parallel paths has finished its work. Now, this is a point that trips a lot of people up, so let's make it crystal clear. A decision diamond is a choice. It's an or situation. You go left or you go right. A fork bar is about doing it all. It's an and situation. You go left and you go right at the exact same time. One is a choice, the other is splitting up the work to get it done faster. Let's go back to our flight booking example. Remember our original text said the member has to fill out an info form and select a travel date. Now, do they really have to do those in a specific order? Not at all. A user could be typing in their name while also clicking on a calendar. So we use a fork to split the path, letting them do both at once. Then we use a join to make sure the system only checks for flights after both of those things are done. Okay, our diagram is getting really good now. We've got the sequence of tasks, we've got the choices, and we've got the parallel work. But there's one critical piece of information missing. Who is actually doing each of these steps? Let's add that final, powerful layer of clarity. We do this with something called partitions, but honestly, everyone just calls them swim lanes. And that's exactly what they look like. You draw lanes across your diagram, and each lane belongs to a specific person, a department, or even an automated system. All the actions in that lane are their responsibility. Instantly, all the confusion about who owns what just disappears. So for our flight process, we can map out our cast of characters. We have the guest, obviously, the person trying to book the ticket. We have the booking system itself, which handles all the background logic. And we probably have an external payment gateway to handle the credit card transaction. Each of these is going to get its own swim lane. So we've learned all the pieces, the basic flow, the decisions, the parallel forks, and the swim lanes. Now for the best part. Let's take everything we've learned and apply it to that messy paragraph we started with and see the transformation. This is the payoff. And there it is. On the left, that confusing block of text we started with. And on the right, total clarity. It's a single visual map of the entire process. You can see every step, every decision like economy versus business, every parallel task, all laid out perfectly in swim lanes that show who's responsible for what. There's literally zero room for misunderstanding here. That is the incredible power of doing this. So why should you actually care about this? Well, with a tool like this, you can map out any business process, whether it's hiring someone or shipping a product. You can figure out exactly what a software system needs to do before you spend a dime on writing code. And you can immediately spot chances to make things faster and more efficient, just by seeing which tasks can happen at the same time. Look, the real magic here isn't just memorizing the shapes. It's about actually using them. So I'll leave you with this one question to think about. What is one messy, confusing process in your job or even a personal project that you could make perfectly clear with a simple activity diagram? Give it some thought. You might be surprised.
Okay, let's unpack this. Have you ever found yourself staring at a really complex process, maybe building software or planning a big event or even just, your morning routine, and wish there was a simple visual way to understand every single step, every decision point, and maybe even things happening in parallel? Well, today we're diving into a tool specifically designed for exactly that kind of clarity. We're exploring activity diagrams. They're a really powerful part of the Unified Modeling Language, UML. And we've got some fascinating insights from some great software engineering resources that should give you a shortcut to being really well informed on this.
That's right. And what's really fascinating here is how activity diagrams act as a blueprint, almost like a universal language for processes. Our mission today really is to help you define what they are, sure, but more importantly, explain their purpose in modeling workflows and system behavior. We want you to be able to identify their key elements and, ultimately interpret and even maybe start sketching these diagrams out from real-world scenarios.
Yeah.
Think of it like gaining X-ray vision for processes.
Exactly. We'll cover everything from the basic building blocks to how they handle choices, parallel actions, even common pitfalls people run into. Get ready for some aha moments, hopefully, that you can apply to almost any workflow you encounter. So let's start at the beginning. What exactly is an activity diagram? And, well, why should you care about them, especially if you're not a developer?
Right. So at its core, an activity diagram models the activities of a system, the dependencies between those activities. Essentially, it represents workflows. If we connect this to the bigger picture, they're invaluable for modeling business processes, analyzing system functionality to maybe identify use cases, detailing individual use cases, and even clarifying concurrency issues, like when things need to happen at the same time. It's a visual language for sequence and flow.
Okay, so it's definitely not just for software engineers then? It sounds like it could be incredibly useful for mapping out any kind of process, right? Like, I don't know, deciding the steps for baking a cake or how a customer moves through a website checkout.
Yep. Exactly. That's the beauty of it. It provides a clear, unambiguous way to show how things flow. A simple example might be data entry leads to processing, which then leads to generate output. It breaks a complex operation into these discrete, understandable steps, makes it easier to grasp.
Okay, let's unpack this. If we're actually going to build one of these diagrams, what are the first pieces we need? The absolute basics.
We start with actions and transitions. Pretty simple, really. An action is just a task that needs to be done. You draw it as a rounded rectangle, and the text inside should be a verb phrase, present tense, like generate report. That's key. Actions are then linked by transitions. These are also called control flows or directed flows. Basically, they're the arrows showing the order things happen in.
And I'm guessing every diagram needs a clear beginning and a clear end. You can't just have arrows floating around.
Absolutely. Good point. We use an initial node, which is just a filled black circle for the very beginning of the flow. And then there's a final node, which looks like a circle inside another circle or a bullseye to mark the completion of the entire flow. Start and end points.
Right. Let's try a real-world sequence then. Imagine becoming a registered member of some online learning system. You maybe first upload a copy of their national identity card, then maybe fill out registration forms, then pay a deposit, right? Then upload a payment slip. And finally, the system would generate an ID and maybe display it on the screen. That's a classic linear flow.
Perfect example. That shows a straightforward sequence. Start node, actions linked by transitions, end node, very clear.
But things are rarely that simple, are they? What if there are choices? What if the path splits depending on something?
Ah, yes. This raises an important question. Because life isn't linear, that's where decision nodes come into play. They're represented by a diamond shape. And they model a conditional flow of control. It's very similar to if-else statements if you're familiar with programming. The alternatives coming out of the diamond are mutually exclusive. Only one path is taken. And each possibility, each arrow leaving the diamond, needs what's called a guard expression. It's basically a condition in square brackets, like valid member. It tells you why you're going down that path.
Okay, so if one path is taken, say the valid member path, the other paths, like maybe invalid member, are definitely not taken at that time.
Precisely. It's one or the other. And then, after those different paths maybe do a few things, they often come back together. That's where a merge node comes in. It's also shown as a diamond, although sometimes people leave it out if the arrows just naturally come back together. But technically, it marks where those divergent paths reconverge. Think of it as the UML equivalent of an NDIF statement in code. It brings the separate conditional flows back into one. Let's consider flight booking again. You become a member, then you hit a decision. Economy class or business class. Let's say guards are economy and business. If economy, maybe the next step is related to baggage allowance, say 30 kg, then maybe another decision, need more baggage. If yes, you go to pay for extra for 10 kg more. If no, you just continue. Business class, business path maybe gets 40 kg by default, so it skips that extra baggage step. Then, after maybe filling forms and picking a date, perhaps these paths merge back, then another decision. Flight is available. If yes, you book ticket. If no, not available, you cancel process. See how the diamonds manage the choices?
Yeah, that makes it much clearer how to map out those what-if scenarios.
Right.
Okay, now, here's where it gets really interesting for me personally.
Right.
What if multiple things can happen at the same time? Not just choosing path A over path B, but like genuinely parallel actions.
Right. Concurrency. That's the domain of forks and joins. A fork is modeled as a thick horizontal or vertical bar. It splits a single flow of control into two or more parallel or concurrent flows. And the critical distinction here compared to a decision node is that all the forked paths are followed, not just one. Control goes down every single path simultaneously, conceptually speaking.
Well, okay, so if I hit a fork, control literally goes down every path that splits off from it, all at once.
Yes, that's the concept. And then eventually, those parallel flows need to come back together. That's what a join node does. Also a thick bar. It synchronizes the parallel flows back into a single flow of control. The rule is, every fork must eventually have a corresponding join. Now, this doesn't strictly mean the activities must run concurrently in software implementation, like on separate threads. It just means their order doesn't matter relative to each other. They can start and proceed independently. They aren't blocked by one another.
Gotcha. That clarifies the concurrent part. Let's think of an example. Enrolling in a university, maybe. After you submit your forms, maybe there's a fork. You could perhaps register for a seminar and at the same time make payments for initial tuition. And maybe also in parallel, you have to attend a university overview presentation, 3 things happening independently. All 3 of those parallel activities would have to be completed, right? And then they'd hit a join node before you could finally start classes.
That's a perfect example. It shows 3 independent streams of activity that all need to finish before the main process continues. Forks and joins are powerful for that.
Okay, but as these diagrams get more complicated, with forks, decisions, lots of actions, how do we keep them from looking like, well, a plate of spaghetti? Especially when different people or departments are involved. How do you show who's responsible for what?
Yeah, that raises a really important question about managing complexity and clarity. The answer is activity partitions, though most people just call them swim lanes. These are visual groupings for actions that have some common characteristic. Usually, it's who performs the action, like a specific department or a role, or even a system. They're drawn as parallel lines, either horizontal or vertical, dividing the diagram. Each lane gets a name, like a customer service or billing system.
Ah, okay, so I can look at the diagram and see immediately, okay, all these actions in this lane are done by the sales team, and these actions are done by finance.
Exactly. It clearly delineates responsibilities and handoffs between different actors or organizational units. Makes it much easier to follow a cross-functional process. You can even have swim lanes within swim lanes, subpartitions for more detailed breakdowns if you need them. Consider an order processing system. You might have swim lanes for customer service debt, fulfillment debt, and maybe finance debt. Customer service might receive order and later send invoice. Fulfillment would fill order and deliver order. Finance might handle payments. Maybe receiving the order triggers parallel activities in fulfillment and finance. Crucially, customer service can perhaps only close the order after both fulfillment has delivered and finance has handled payment. That would show a join node crossing swim lanes, indicating synchronization is needed across departments before proceeding.
That visual separation is huge. Okay, one more structure question. What about tasks that need to be repeated? Loops. How do activity diagrams show something needs to happen over and over again, like iterating on a design?
Good question. There are a couple of ways. One, less common, is putting an asterisk inside an action state. It kind of suggests it might be performed more than once. However, a much more explicit and generally preferred method is to model iteration using a decision node and looping arrows.
Okay, why is using a decision node better than just the asterisk? Seems simpler just to put a star.
Well, the asterisk is a bit vague. It doesn't clearly show why or when the repetition stops. What's the termination condition? How many times does it loop? By using a decision node, you explicitly model the loop. You have an arrow coming back to an earlier point in the flow. And the decision diamond has guard conditions like more iterations needed and iteration complete. It provides much, much greater clarity about the looping logic. You know exactly what condition keeps the loop going and what condition breaks it.
That makes total sense. You need to hold it to stop. Okay, think about software development. A UI engineer develops the prototype. Then the project manager shows the prototype to the client. Then you hit a decision. Is the client happy? So maybe the guard is client not satisfied. If that's true, the flow loops back to the UI engineer to modify the prototype. And this continues until the client is satisfied, which would be the other guard client satisfied, leading out of the loop. That seems much clearer.
Exactly. That captures the iterative process perfectly using the decision node for the loop control.
So we've covered a lot of powerful elements: actions, decisions, forks, swim lanes, loops. With all this capability, where do people typically mess up? What are the common mistakes to avoid when you're creating or just reading these diagrams?
Probably the most common mistakes, and the ones that cause the most confusion, revolve around mixing up forks, decisions, merges, and joins. Getting those wrong really undermines the diagram. Remember, a fork means control goes down all paths concurrently. A branch point, the decision diamond, means control goes down only one path based on a mutually exclusive condition. People often use a diamond when they mean parallel, or a fork when they mean a choice.
Right, that distinction between all paths and one path seems critical. What about the merging elements? Merge versus join.
Similar issue there. A merge point, the diamond again, brings together alternative paths that came from a decision. It's like the NDIF. A join, the thick bar, specifically synchronizes parallel flows that started at a fork. You have to wait for all those parallel activities to finish before you can continue past the join. Using a join where you just need to merge conditional paths, or vice versa, completely misrepresents the process logic. And another common slip-up is forgetting the guard conditions on decisions and loops. They must be there explicitly in square brackets to make the logic clear. Ignoring these distinctions leads to real ambiguity. You know, what's fascinating here when you step back is that activity diagrams, although they came from software engineering, really offer this universally applicable way to see and improve any complex sequence of actions. They push us beyond just simple flowcharts to accurately model decisions, things happening in parallel, who's responsible, even repetition. It's incredibly precise.
So what does this all mean for you listening right now? Think about a complex process you deal with regularly. Maybe it is onboarding a new team member, or troubleshooting a recurring problem, or even planning your next big project, personal or professional. How could sketching out an activity diagram help you visualize that, help you optimize it, or even just explain it clearly to someone else? You might find it's that shortcut to clarity you've been looking for. We really hope this deep dive into activity diagrams has equipped you with some powerful new ways to understand and maybe even streamline the world around you, one activity at a time. Thanks for joining us.